Two space rocks drifted toward each other, somewhere in the early solar system, touched, and just never let go. That was probably 4.5 billion years ago. We just got our first close-up look. Here's what's strange. Astronomers watching from Earth thought asteroid 98,943 Torifune was just one oblong rock, kind of lumpy, nothing weird. Then the Japanese spacecraft Hayabusa flew past it earlier this month, and the images came back showing something nobody expected. Two completely separate lobes touching at the middle, stuck together like a pair of mismatched grapes. Look at the left one. It's blockier, more angular, like a chunk of sidewalk. And look around its edges. Those aren't shadows. Those are individual boulders, just sitting there loose on the surface. Torifune is what scientists call a rubble pile. Not one solid rock, but a loose collection of debris held together mostly by its own weak gravity. You could probably kick one of those boulders free. And here's the detail that really surprised researchers. No craters. Anywhere. On a rock this old, that's genuinely odd. The leading idea is that when anything hits the surface, the rubble just shifts and absorbs it, like punching a pile of sand. Now look at the right lobe, rounder, and across its sunlit face, you can see where direct sunlight makes it almost glow compared to the shadowed zone toward the contact point at the lower left. This lobe probably formed on its own, somewhere else in the solar system entirely. Scientists think each lobe was its own small body first. They drifted close. Gravity nudged them together, and they collided so gently, maybe just a few centimeters per second, that instead of shattering, they just held. The same story happened with Arakoth, the distant object New Horizons flew past in 2019. Slow collision, soft join, billions of years together. And right here in the middle, see that deep shadow cutting between the two lobes? That's the contact zone, the neck. It's where two completely separate histories of the solar system meet in a single frame. Torifune is only about 4 soccer fields long in total. It crosses near Earth regularly. It is not a threat. But Hayabusa 2 isn't done. It's now on its way to a completely different asteroid, one that spins so fast it might fly apart and might be hiding ice. That encounter won't happen until 2031. Two objects that formed separately in different parts of the young solar system somehow ended up drifting close enough and slow enough to stick. One gentle touch, and they've been together ever since, longer than Earth has had complex life. What are the odds that Hayabusa 2 would zip past at exactly the right moment to finally show us what that looks like up close? We'll be here tomorrow with whatever the data shows next. Subscribe so you don't have to remember to come back.